If you're wondering what the heck this is, you're not alone. If you're wondering who the heck this guy is, you're also not alone. But you might want to stick around because this product right here could be the biggest bang for your buck you've ever seen. Oh, and this guy? Just some schmuck on YouTube who also happens to be a product design engineer. If you haven't seen a more interesting thumbnail in the recommended videos yet, then stick around and welcome to the channel. So first, I wanted to show you guys what this product was intended to be to begin with. It doesn't really matter for what I'm going to talk about because I don't really intend to use it for its intended purpose. But if you wanted to see, there's the specs, 250 foot-pounds. It comes with a box with all that stuff that you see there. You know, some of these, which are double-ended lug nut sockets for various different sizes of vehicle make, I'm sure. And yeah, comes with this little thing right here, so you can plug it in cigarette lighter or to any 12-volt battery. So why is this thing special? Don't need that. Well, so the first reason is it's 36 freaking dollars. Second reason, 250 foot-pounds of torque for 36 freaking dollars. Do that equation. That means torque per dollar equals about the best I've ever seen. I searched and searched and searched. I couldn't find a better torque per dollar than that. Especially not in anything name brand. That's a batterized drill, or even I guess there are some air compressors that are like from Harbor Freight that might be able to do that, but still, they won't be portable unless you bring a compressor with you. So now there are some no-name brands on Amazon that have batterized drills that are claiming ridiculous numbers that I find highly suspect. But even so, the batteries are going to go bad insanely quick. Like the one that I saw for 90 bucks claiming to make 330 foot-pounds, that battery has got to be just absolute garbage that comes with it. So that means after about 3 to 6 months, you're going to have a paperweight, which is exactly what this is if it didn't have a battery. So now you might be saying, well, that one doesn't come with a battery either. No, but it comes with the ability to be able to use any battery right inside the box. You don't have to rig up do any soldering or special hacking. And 12 volts are everywhere. So this basically has a battery that'll never go bad because you can always find a 12-volt battery somewhere. Most likely, it's attached to the thing that you're working on, or it is very nearby what you are working on. So the practical application for this to me is, if you can't justify the cost of a name brand like Rigid, Milwaukee, DeWalt, fill in the blank, that makes this much torque in a batterized package, because you don't use it that often. You're not taking lug nuts off. You're not a drifter or a weekend racer or something where you need that much torque really quickly all the time on demand, portable. So and the other thing is you might not have an air compressor at all, or you might have a very weak air compressor, and so you don't want to go out and spend roughly the same $200 to $400 to buy a nice impact, batterized impact, or buy a compressor that's big enough to run an air version of an impact. And you just need to break loose a stubborn bolt every now and then. That is the wonderful biggest bang for your buck application situation that you might be finding yourself in. That, again, normally I don't care about what the application is for something. I just want to take it apart, see how it was made and how good I think it was made from what I can see. But this is kind of a unique product that I think, for if you're in the right situation, for $36 and 250 foot-pounds of torque, that's pretty good. Again, if you're just need to break loose that stubborn bolt every now and then. You don't have a compressor and you don't have a $400, Milwaukee 1/2-inch drive with just all the torque in the world. So, all right, enough about the application. Let's get into it and see what's what. From the outside, it looks pretty cheap, guys, gotta say. This orange peel stuff is like straight out of the 70s, Black & Decker, the finish on the mold, these just shallow dowel dot stippling, again, straight out of the long time ago. Nothing, no grip, no rubber overmolded grip. It's got a paper sticker for the logoing, and it looks like somebody used a label maker to put the part number on this thing. And by the way, there it is, if you wanted to know. And if you missed it, there's the model number that's on the outside of there. Cowhawk, all the pertinent information, and I'll also leave the Amazon link in my description if you care. Again, $36 prime shipped. Can't argue with that. This feels like you would expect any impact. It's blackened. It has to be tempered, machined. It doesn't look like, it looks like something you'd get from Harbor Freight, but temper is temper. That's old technology, so that's probably as durable as any of them. It's not that pretty looking. It does have the ball indent and trigger that looks like it could have come off a blender or something from 40 years ago. I don't know. All right, let's take it apart. Okay, first, so that is a fuse, and I'm pretty sure there's no electrical. Yeah, that's just a screw in there, and then there's nothing on that. So that's just a spare fuse, and it probably goes somewhere inside of here, or could. Oh yeah, probably. Yep. Okay, so there's the real fuse. Okay, injection molding quality, about like I would expect. Really, it's not the quality, the processing quality and the tool quality is not that bad. It's really smooth surfaces, not a lot of grinding marks. Really, the cheapness here is in the material and the conceptual design. So there's not a lot of ribbing. There's not a lot of detail that went into this. It's bare minimum. And really, judging by the weight of this, I'm going to say that this is polypropylene. It's a cheap product, so they're not going to call out what the material is or have a part number that you can look up, because that's just what cheap products do. So I'm going to guess polypropylene, which is like what a cheap Stanley toolbox or something, they get for like $9 at Walmart would be. That's just my guess. That's what it feels like, and it would make sense at the price point that this is at. So, all right, moving on. Now this is the fun part. How the hell did they get all that torque out of here for only $36? So they had to have cut corners somewhere, and we already know one corner they cut. They cut the time. So you notice when I was revving it up, let's see if I can make this thing sing without killing myself here. Let's see. All right, so, all right, everybody look out. Oh, it did it. Ha. Can't argue with that. So notice it's not engaged. I can just hold on to this. See, it only impacts, if you hold it, I'm not going to do it because it's probably going to jump out of here, but you have to hold the trigger for like 2 to 3 seconds to get it to build up enough inertia to do the impact. And so that's the only variable in this equation that's gone down is time and maybe overall weight, which was, they had to put the extra weight in there because they have a low power motor. So time. The amount of time it takes you to get to the 250 foot-pounds of torque impact, the amount of energy, time it takes to build up the inertial mechanical energy inside of here to be able to translate that into a 250 foot-pound torque impact is what you're paying, what you're saving. That's what you're getting you're paying less money for more time. And so how'd they do that? Well, so they did it with a cheap motor, low power, cheap motor, and a bunch of weight and a bunch of diameter. Look at this diameter compared to that diameter. So those are three things that are kind of at a premium in electrical products, especially tools, impact drivers, is you're trying to get that space down to as small as possible. You're trying to keep the weight as low as possible for the comfort and fatigue of the user. And you're trying to get it to be as fast as possible, have a fast, powerful motor that just churns out those impacts over and over and over again like that, not having to wait for something to build up to produce the impact. So that's how they did it. Cheap motor, bunch of weight, big diameter, which again increases your angular momentum. So you just, it's almost like what are those merry-go-round thingies that are at the park when you were kids that they got rid of because kids kept dying, that you had handlebars on them, and a 2-year-old could get one moving. And of course, an 18-year-old could get one moving a lot quicker. But the 2-year-old could eventually get that big old heavy turntable to start turning as fast as he could run. It just took him longer. And that's basically what this thing is. It's just more weight with less power, taking more time to generate the same thing at the other end. So, all right. Now this switch, this is again more cost savings right here. This is a reversing relay. This thing has no smarts in it whatsoever. That is a brushless motor, a reversing relay, and a plus and minus. That's about as simple as anything with an electrical motor can be. You put the switch up into here and it reverses the polarity. It connects different contacts that make this one go to this one and then this one go to that one and vice versa. Simple as pie. Not even a potentiometer in it, because again, it's just on off. There is no, it doesn't matter how much. It's just yes, no. Reverse, yes. Forward, no. All right, well, let's get this apart and see what else we can see. Okay, so there is a bearing that feels like it is made out of something heavier than aluminum, but based on the color, it's definitely cast. Based on the color, I'm going to say that it's iron bronze. They do make bronze with a heavy iron content that it will rust, but it makes a great bearing, really hard. It's just the downside is it will rust, and that's the only compounds of brass that I know, or bronze that I know of, that are this color. So they could have just cheaped out and made it out of, I don't know, the cast steel is not the easiest thing, the cheapest thing to make. So again, I'm gonna go with bronze, iron bronze on that. And now we have so that is the bearing for the middle shaft, and that thing looks like its tolerances is plus or minus a crap ton. Again, on a bearing, you typically don't want looseness. You want proper fitting, and that's like a washer. It's like washer tolerances on there, but that is a bearing. That's what that is supposed to be. So, all right, this shaft. So what is this? This is, well, that's a thrust bearing, or maybe it's just a retainer for these. Yeah, it's a thrust. It's kind of it's a separator / thrust bearing, just stamped sheet metal. Feels like steel. See how simple sheet metal can be? You need something that goes into 2 holes instead of pressing pins into sheet metal, into holes in a sheet metal. Just bend prongs out. Simple, cheap, effective. All right, now, okay, so there's a bearing that has been welded, and so we have like a sheet metal girder here, faceplate on the motor that holds a welded in bearing of some kind. It wouldn't get, considering that it's welded, I'm guessing that has to be steel. I don't think you can weld steel to bronze. And that is just a simple spur gear reduction, maybe 2 or 3 to 1. So again, not a lot of power going through here. They're relying on the time and weight, a bunch of weight and a bunch of time to get to the same mechanical impact on the end. So how does this work? This is the probably the coolest part. What I was most interested in is, so this is a centrifugally operated mechanism right here. See that push out as it starts spinning up, and it gets faster and faster and faster. These eventually reach a breaking point and you can see how the spring is on a flat, and so it's kind of hard to explain, but there's very much it's like a limit switch. It's not, once you get here, it's not the same amount of force required to get to there. It just kind of wants to go, and that's because of the nature of this, the camming groove that they put in there. It limits it, and then as soon as it starts to break, it gets easier. It gets easier to break out, and so that's probably to make it abruptly open, and then it opens up that right there, which makes contact with that. And then times 3. 1, 2, 3. So ideally, they should open all at the same time. But because the bearing, holding these in place, it doesn't need more than one to come in contact. And it looks like, wait, is it just 2? Oh no, it's 2, not 3. Yeah, so it's just got 2 places. And so if I can see if I can get it to actuate from the outside. No, can't do it. Oh, maybe. Anyway, you guys get the idea. Yeah, so those teeth open up and make contact with those grooves. So simple, effective, cheap, and if you're in the right situation, it could be everything you need. All right, guys. Well, that's all there is to this simple little guy. $36, 250 foot-pounds of torque guy. If you're in the situation you can use this, I hope this helps. If you like the video, give me a subscribe or give me a like. And if you really like the video, give me a subscribe and hit that little bell icon to receive notifications when I post another product teardown. If you have any questions, leave them in the comments. I try to answer every single one. If you didn't like the video for some reason, let me know why. Tell me what I did wrong, what I could do better. Always open. All right, guys, I will see y'all next time.